ducted split heat pump. Engineered for extreme cold, this advanced system ensures efficient heating down to minus 13 degrees Fahrenheit and offers seamless cooling for year-round comfort. Powered by Bosch's inverter technology and featuring low GWP refrigerant, the IDS Ultra is designed to meet modern energy needs while offering unmatched reliability in any climate. Take advantage of significant rebates and tax credits, such as those provided by the Inflation Reduction Act. For example, households with income below 80% of the area median income can receive up to $8,000 in rebates for installing a high-efficiency, ducted split-system heat pump. Plus, a 30% tax credit on installation costs, up to $2,000 annually, is available through the Residential Renewable Energy Tax Credit. With lower energy consumption, a heat pump can potentially help reduce your utility bills over time. Unlike traditional on-off compressors, the Bosch inverter compressor adjusts its speed in 1% increments to match the cooling or heating load precisely, significantly reducing energy consumption and operational wear. This variable capacity allows for superior temperature and humidity control, operating between 33% and 187% to meet your home's exact needs. The compressor modulates its speed to achieve the indoor coil target temperature with specific target ranges for heating and cooling. This eliminates the risk of freezing the coil while providing superior comfort and dehumidification in cooling. With features like accelerated cooling mode and variable speed indoor air handler, the Bosch IDS system provides enhanced humidity control, making your home more comfortable. The new Bosch IDS Ultra features an innovative technology called enhanced vapor injection to enable efficient heat pump operation in cold climates. Enhanced vapor injection is enabled by the addition of a plate heat exchanger, an additional electronic expansion valve, and complemented by an inverter compressor. The system operates much like a conventional heat pump. When additional capacity is needed at very low temperatures, an expansion valve opens to allow a portion of refrigerant to bypass the traditional cycle. The vapor injection process begins as a portion of the liquid refrigerant is diverted through an expansion valve into the intermediate heat exchanger, transforming it into a cool vapor. This diverted flow is used to further subcool the main flow after it has passed through the indoor coil, heating the inside to the desired temperature. This ensures consistent and comfortable indoor temperatures. By lowering the refrigerant temperature after leaving the condenser, more heat can be absorbed from the cold air by the evaporator, extending the heat pump's operating range down to minus 13 degrees Fahrenheit, making Bosch heat pumps a great choice for colder climates. Pairing Bosch IDS products with the correct air handlers, furnaces, and cased coils is crucial for peak performance. Bosch IDS systems are designed to work with most 24-volt AC thermostats, seamlessly pairing with a variety of third-party air handlers and furnaces, ensuring broad compatibility and installation ease. Always consult Bosch's model compatibility charts and installation manuals to ensure proper system matching and optimal performance. Our certified expert installer network is ready to assist with installation if needed. Designed with contractors in mind, installation and maintenance are streamlined, ensuring seamless integration and longevity while meeting the demands of homeowners and builders.
Well, hello everyone. Thank you for joining us once again on Did You Know, the ESCO HVAC show. We're so grateful that you are all spending time today to learn about new technologies and innovations coming to our industry. And we really want to know where you're joining from. If this is the first time visiting, we want to make sure that you hop in here and tell us a little bit about yourself and from the industry. So welcome to put things in the chat. Julian, thank you for joining us. Yeah, this is a really cool piece of equipment. I'm very excited about it. That last little photo in that entry, that was me in the whole gold sequin suit at AHR this last year, getting people's attention with new products. It was kind of goofy, but boy, I had some fun. And Tom, thanks for joining us. Mr. Tebby out here, thank you, sir. And actually, Mr. Tebby brought up a great point. We were just talking just a little bit ago. Now that we're into the new year of our show, we want to get your input. We want to know the things that you've enjoyed about the show, the things that need to have a little bit of improvement, topics that you would like to have covered. So I'm going to throw out, let me grab over here to the QR section. You can grab that link and copy and paste if you want, or you can just grab that QR. Oh my goodness, I'm sorry. Let me grab that over to the side. So that is not in our view. Come on now. Sorry about that, Mohamad. All right, so that form will take you over to a job forum. That'll get some input for where you would like to see the show go this year, because we're really moving into some new technologies and we're gonna have a lot to talk about, and we need to know what you would like from us going forward, and this will help plan the topics that we cover on the show for 2025. So today we are very excited to have some new faces on the show from Bosch. We have Mohamad Nasab. Mohamad is the product management manager for Bosch. We also have Trevor Shane, which is the digital solutions lead. Gentlemen, thank you so much for joining us today. How's the weather in your area of the woods?
Cold.
Yeah, where are
Yeah,
you at,
today's the
Trevor?
day we need the Ultra.
Oh yeah.
Yeah, Trevor, where are you at?
Watertown, Massachusetts.
Oh, okay. And Mohamad, I know you're in Canada.
No, actually, the background is in Canada.
Oh, okay.
Physically in Watertown, Massachusetts as well.
Oh, okay. All right. So yeah,
Yeah.
absolutely, plenty of cold.
Yeah.
All right. I'm gonna hop over here in a chat, keep an eye on things. Oh, yeah, we got quite a few people in here. George, thank you so much for joining us from Western Kentucky. We've got Kendrick. Kendrick has been hanging out with us a lot, and I'm glad that you're with us today in Chicago. It's kind of cold up there too. I know here in Indianapolis, we got like 12 inches of snow. Catherine Donahue over in Hillsboro, she is a regular on the show. Katie's actually been with me since like back in my old Johnstone days when I first started doing this stuff, which was like even pre-COVID. Paul Leonardi, thank you for being in here with us. Howard's out here joining us from Thornton, Colorado. David, glad you're here today. Yeah, up in Ontario. So this is right up your alley, David. So when we start talking about capabilities of new heat pumps, it's products like this that really get me excited. Hey, Nick, join us from Massachusetts as well. Thanks for being here.
Yeah.
Right. As technology changes, we are really starting to push our envelope. And I know I almost burn out that whole automotive comparison, but it really is very similar, right? When we made the transitions from a lot of those mechanical controls on our internal combustion engines into automations and controls and algorithms that were using pressure transducers and temperature thermistors, we could take a product that was functional and decent and improve its performance very significantly. And that's really what we're starting to do. Hey, Chip, hey, glad that you're joining us today from Kalamazoo. So let's dive a little deeper into what's happening in the world of Bosch. And so we've got quite a bit of things that we can go over today. While I'm getting that presentation ready, Trevor, Mohamad, why don't you guys share with the community a little bit your experience and background in the industry?
Yeah, sure. Actually, you were talking about automotive, and that's a perfect segue because that's the industry that I came from.
Oh, very.
So I've been with Bosch about 9 years
Mhm.
now, and 8 of those were in the automotive sector. So
Oh, very good.
I finished as an R&D engineer. I was working on thermal systems and refrigerant systems for the next generation of EV.
Mhm.
And it is really interesting to see the parallels
Mhm.
between the automotive
Yeah,
industry and residential and commercial HVAC now. So
absolutely.
now I've been with Home Comfort about 1 year, and it's been great.
Oh, that's cool. So yeah, we got a lot of stuff we could talk about. We can go down the automotive rabbit holes and we'll have stuff to talk about if we need to. Fantastic. Mohamad?
So I've been in the industry for about 7 years. With Bosch, 3 years of them. For that, I was with another company. I was working on variable speed product, both ACs and heat pumps. So
Very good.
I'm very familiar with inverter equipment.
Hmm.
And my background is in engineering. I started my career as a product development engineer, and at Bosch, I transitioned to product management.
Very nice. All right. This is what I enjoy. I enjoy getting a variety of perspectives from our industry. I always say that our industry is plagued too much by middle-aged technicians like myself, which is great. We all need to learn about what the products look like once they hit the field, but the engineering that goes into them, the research, the design, there's a very significant amount of information that doesn't get addressed in the industry as much as it should. Hey, thank you very much for joining us, Brian. We're going to talk about a variety of different things along the way here, so we'll keep that in mind as we get there, though. All right, so let's go ahead. We got a couple different presentations that we'll be able to work with today, and we're really going to spend most of the time on the IDS Ultra because it's the largest transition. It's the highest efficiency. It's set so many standards in our industry. It's progressed the cold climate heat pump challenge from the U.S. Department of Energy, so there's a lot of things to talk about this. And to some of you, this may be a new product, especially when we get into some of the technology that we're using. And so, whether you're a contractor or an educator, there's going to be things in this presentation that might not be as comfortable for you as they will by the time you get done with this, right? There's a whole lot of talk about these cold climate heat pumps, and which really it's we got classifications, we have a terminology for it, but we're really talking about heat pumps that are capable of running solely as the heat source in multiple areas of the country. And maybe we'll take a little time. We'll compare the different product heat pumps from Bosch and to show different climate areas that they'll work in. So we do want to make sure that you know a disclaimer. This is for educational purposes, right? So we're here to train. We're not here to of course, we always sell things along the way. We're all in the business of selling things, but we're really here for education and training, right? So we want to help you get more comfortable with new products and best practices in our industry. So, all right, let's talk a little bit about this new ducted split system solution from Bosch. All right, where do we want to start on? How about we start on this one? All right, who's going first?
Mohamad.
Yeah, so I can go first.
Okay.
So really, why did we launch a cold climate heat pump? And this slide covers the reasons from legislation and regulatory landscape.
Okay.
So you can see that the DOE has a new federal minimum efficiency ban on non-condensing furnaces starting 2029. Of course, this is up to legal challenges now,
Sure.
but it really shows where the DOE is heading, right? All eyes are on electrification, and gas furnaces, we see them as to continue to be an option, but we also want to provide an option for people that choose to go with a fully electric system, and especially those in the northern climate. So other than the DOE, also, but part of it is the EPA, which is responsible for the Energy Star program. You can see that they have a specific criteria for cold climate. So another push for cold climate heat pumps. And then a general push from a legislation perspective on heat pumps in general, right? We've seen the IRA, we've seen also, again, the EPA draft legislation to remove cooling and gas furnace systems or specific gas furnace systems from the Energy Star program in 2026. So a lot of push that is coming from the government, whether it's from the DOE, EPA, or also from Congress as part of the IRA for heat pumps, electrification, and we also want to be part of it, and we want to provide an option for it. This is kind of what this slide covers in a nutshell.
And hopefully people are starting to be aware that this is not just in the HVAC industry that we're making a lot of these strides and transitions. When we mentioned that whole non-condensing furnace, we're also going to be looking at that in our water heating space as well. So we're going to be transitioning into a lot of new technologies, not just in HVAC, but in other energy moving sources. So we'll spend time in 2025 diving deeper into our higher performance water heating solutions, which sometimes we'll call heat pump water heaters. We'll call them hybrid water heaters. And there's a variety of combinations in there. But we will start talking about more of those here for 2025 because we're going to be making this same style of transition in the water heating sector as we are looking at into the HVAC sector of things. And when we start looking at efficiency and rebates, I actually just did a really good podcast with the Department of Energy. I'll be releasing that here in a couple weeks, talking about different types of incentives and rebates and ways that we can stack some of these things, because there's rebates that are coming through not only at the federal level, but at state and local levels to encourage us to look at some of these higher efficiency products. And it's making it a lot more affordable for the homeowner, because that's one of the first things that we hear from the industry when we say, "Oh, we're bringing out new technology." They go, "Oh, great, that's going to be expensive.
Interesting.
Oh, it's
Yeah.
going to hurt the bottom line." And when we actually stop and look at it, you're going to find that a lot of these solutions are actually a much better fit for your long-term goals,
Hmm.
for cost and energy conservation. And so there's a whole, especially Mike's joining us from California, Indio, California. California is even more aggressive than a lot of the country on some of these initiatives and rebates as well. I mean,
Mhm.
we haven't always talked about heat pumps in California before, but now we're actually starting to see a very significant push for heat pumps in California. They're used as, primary energy sources. And so we may end up diving into that a little bit later, but we definitely want to hang in and talk about this equipment first.
Hmm.
Okay. Oh, look at, let's talk about some of these trends that we're actually getting. Dave, Jim Bergman, thank you for joining us, sir. Anybody know that name out in the industry? Hope so. Probably every technician on here today. All right. So yeah, let's talk about some of the trends that we're seeing across the country that is driving some of this innovation.
Yeah, so some of these trends, this is from the Washington Post. It shows um, the U.S. residential heating sources, and you can see that the Northeast heavily depends on oil for heating. Midwest is a mix between natural gas and propane. The South is electric, and Northwest is wood. So there is very low heat pump penetration when it comes to above the Mason-Dixon line,
That's the
right?
traditional.
You can see that the Northeast electric is not the primary solution, nor in the Midwest. And of course, that is part of it is because there hasn't been really a heat pump that can deliver the capacity needed for those cold climates, and not only deliver the capacity, but also at an efficiency level that the consumer is comfortable with.
Yeah, indeed. We look at particularly some of those southern areas that were using electricity as, dominant energy sources. We can go down through Florida and, talk about heating sources in Florida and find that there are traditionally have not been a lot of heat pumps in Florida because the usage of heat wasn't as excessive. And so we have a lot of electric resistive heating used in these areas, straight electric furnaces with AC. And so when we start looking at energy use and energy demand, we are starting to put a pretty significant impact to energy consumption on our electric grid. And so now we have consumers looking at it as an opportunity, going, I've never had a heat pump in the past, but now I can actually start looking at, a new form of heat that is a fraction of what I would have been spending for my heating use previously. And we're going to see a lot more of that, especially in those southern areas. Places that traditionally didn't look at heat pumps as their heating source are, and that's why we wanted to, to talk this heat pumps for all climates, because now we're starting to look at all climates being good candidates for heat pumps. Now, are they the right candidate for a cold climate heat pump? Well, we'll talk about that, because maybe it depends on what you're looking for, what type of equipment you're investing into, and the technology that comes along with that one. All right. So, anything else on this slide that we want to dive into?
Think that's all just showing the picture. Um, there is an opportunity here, right, for electrification, and it clearly shows where heat pump penetration is or has been in previous years, and where it's been uh, lacking.
Yeah, absolutely. Tom Leck, thank you for joining us. Glad to have you here with us. HVAC TV, grateful that you're joining us today. Yeah, good afternoon to you, Tony. All right, so let's move along a little bit here. And let's talk a little bit about the challenge and where this equipment was developed from.
Trevor, you want to take that one?
Yeah. So there's a little bit of history here that I think was kind of missed, I think. And it's kind of interesting coming from automotive because I knew a little bit about it, but
Mhm.
when I came to residential, it seemed like nobody really knew about it or thought about it.
What?
So one of our products, the mini split system that we have a version called the Max Performance.
Yes.
And this is using a technology, so this is inverter driven,
Yeah.
but it's also using a technology that we kind of never really covered before, but it's been out there, right? So if we look at Max Performance Mini Split, this will provide heat down to minus 22 degrees Fahrenheit.
Mm.
And some people just assume, oh, well, you just run the compressor more.
Yeah.
But that's not the answer, actually.
Okay.
So that system's using a flavor of a technology called flash tank vapor injection. And the next step to that is what we call enhanced vapor injection.
Okay.
And this is the technology that's enabling the Ultra to provide 100% capacity at -5 and continue to run down to -13 degrees
Mhm.
Fahrenheit.
Yeah.
So it's kind of an evolution, right? So we're
Sure.
building on these blocks of knowledge that we already have that have been out there in the market, but enhancing them.
Okay, so that flash tank vapor injection on ductless, how long has that been in the industry approximately?
Oh, that's a good question.
Caught you
But
on the
it's like
spot on that one, didn't I?
it's like thermodynamics, right? You start thinking back on it and you go, "Oh,
Yeah.
this is 100 years old," right?
Right.
I don't actually know when the Max Performance line came out. I haven't been in
More
the
than
home
5
comfort
years?
for long. Yeah, definitely more than 5.
Right.
I put in a mini split system at my previous house in Michigan, and I had the option to do Max Performance, and that was at least 5 years ago.
Okay. Yeah, and that's what I was looking for because I myself am looking at the Max Performance as a ductless option on a little barn dominium that I'm building, and so
Mhm.
I keep looking at that going, "Man, that's a lot of heat capacity." The extended heating data tables for that is insane. We'll cover that
Yeah.
one on another episode of the performance that we're getting out of the ductless, but we're gonna stay primarily on our ducted solutions for today.
Mhm.
Yeah.
Yeah. Just want to add to that slide. The DOE called climate heat pump challenge. So as part of the shift that we're seeing in the legislation and regulatory perspective, which I spoke about in the beginning, and also the low penetration that we've been seeing in the cold climate world, we participated in the Department of Energy's cold climate heat pump challenge.
Yes.
So this was a challenge hosted by the Department of Energy, and the goal of it was to advance heat pump technology, is to provide a solution to customers that wanted to stay in an electric solution, living in colder climates. And Bosch joined this cold climate challenge. We joined in 2022, and this challenge had very stringent requirements. One of them was it needed to have 100% heating capacity at 5 degrees
Mhm.
and operation down to -10 at least. It also needed to meet the Energy Star criteria, and it also had some specific control logic and staging requirements. Um, so we had a prototype ready in Q2 of 2023, and we did lab testing at the Oak Ridge National Lab in October of 2023. We then did field tests between October, and the field trials are still ongoing, but we did go to commercialization. We thought that we had pretty comfortable data to go with commercialization in October of 2024. So the product is now ready and is for sale. And we've been seeing a lot of interest from our customers and also from our distributors. And the DOE right now is looking at the data from the field trial and is engaging with utilities to, drive rebates for those specific DOE cold climate heat pumps. So a lot of interest also from the homeowners that participated in our field trials. Um, Everyone has been saying that they're liking the heat pumps, and even two of them had dual fuel systems, or I think two of them had furnace only systems and transition to a complete electric solution, and are saying that they find the heat pump very, very comfortable.
Yeah, I've actually read those reviews of those field trials, and those are very, very exciting because those are northern installations of people that are used to
Mhm.
gas furnace applications
Yeah.
primarily, and are really seeing the benefit of these high capability heat pumps. I was actually fortunate enough to see the IDS Ultra in test down at Oak Ridge. I went down this last summer to do some behind the scenes class and visit the facility, and I'd seen the Ultra. I was like, oh, we're getting closer, because I'd seen a preview for it at AHR, and then I seen it at Oak Ridge, and went, okay, now we're
Mhm.
getting pretty serious. So the products are actually starting to hit the ground now, which is incredibly
Yeah.
exciting.
So this is just the timeline. You can see the field trials, and it's available now. These are some of the features. So as I said, the main one here is that it's providing 100% heating capacity at 5 at a 2.1 COP. A lot of times you see heat pumps that are providing capacity, but at an efficiency that is very low. This heat
Mhm.
pump is very efficient at low ambient temperatures. Um, and we did not forget about cooling. So it's achieving a 19 CO2 also in cooling,
Very
and
cool.
it's able to go down to minus 13 Fahrenheit. If the temperature drops below minus 13 while the heat pump is operating, the heat pump will continue to run. It will not stop at minus 13. If it shuts off, it won't come back on until it's at minus 13. But if it's already on, it will continue down. And at the Oak Ridge National Lab, we saw it continue to go down to minus 25 even.
Really? Okay,
Yeah.
that's good to know. So
And if you're at minus 25, you're going to need heat. You're not going to stop
you're
calling.
going to have multiple sources of heat.
Yeah. Yeah.
Yeah, well, that's really good to know, because I was kind of concerned with that number, because I just did a cold climate heat pump comparison, looking at different pieces of equipment and capabilities at sub-zero temperatures, and there wasn't a whole lot of test data. There was some from AHRI, and I noticed in the extended heating data tables it stopped at minus 13. I'm like, wait a minute. I am pretty positive that they were running that unit down like closer to minus 20 when I was at Oak Ridge. And so that makes sense. So if it's
Yeah.
already running, so my compressor is already warm, recirculating oil, then I can continue to run down lower than minus 13. So once it gets to its set point and shuts off below minus 13, it's not going to come back on until it reaches minus 13, and then it can reestablish the cycle. Oh, that
Yeah, and of course, if you're living in such climate, we expect that you have also electric backup, right, to handle that situation. That covers it.
Okay, yeah, that's great. Okay, so I can work on my tables now and go, there's more, but it's going to be in a slightly different
Yeah,
style.
it will eventually shut off if it. Of course, we have protection. Reliability is very important to us. So if it hits a suction pressure limit, it will the compressor speed will limit itself, and it really depends on the condition, the installation. At the lab, we didn't see it shut off at minus 25, but everything depends on the install, right?
Sure.
So
All right. So when we start talking about capabilities of heat pumps, remember there was a time when we looked at balance points of a system completely based on our heat gain, heat loss. Now we actually start re-looking at our balance point from an efficiency perspective. Because if we look at this particular unit at 5 degrees, I'm still putting out 100% capacity. And I'm doing that at a COP of 2.1. So 210 times more efficient, approximately, than electric resistive heating alone at 5 degrees. And so, what we previously looked at as a BTU balance point is really starting to get challenged now by efficiency, because with this particular unit, I would look at that at 5 degrees and go, okay, I've still got enough capacity. Let's just keep on running until I get down to a mix of my heat gain, heat loss balance point and my energy efficiency balance point. These units are really pushing the boundaries of capabilities for heat pumps, more than we've ever looked at in the past. And so it's kind of exciting. I get real intrigued when I see the technology and how much it's changed. We just had a comment that came in a while ago from RV10 Flyer, was going to be looking at a 15 SEER after all the snow is done from RE Michael. Well, I would like to challenge you to kind of relook at things, because here we have, that would be the light. So if we're looking at that
Mm-hmm.
15 SEER, you would be looking at an IDS light that is rated down to 3 degrees Fahrenheit, right? Well, let's look at our other options, especially as we start approaching this Ultra. So let's talk about some of the differences in operating ranges within this different groups of heat pumps.
Yeah, so you can see we provide a heat pump for all climates, right? If you live in Florida, you don't need a cold climate heat pump, and we have an option for that. So we have a full range of heat pumps for all climates. If you live in a northern climate, take a look at the Ultra. If you live in Florida, take a look at the Light Plus Premium. If you live in a state that is driven by rebates, then the premium would be a very good option. So really an option for everyone. And this is what we strive to achieve, inverter technology, right? They're all inverter driven. So very efficient heat pumps. Feel free to give them a try.
Yeah, and I really like the way that you describe these features of the units, because it challenges a norm in our industry that I personally have been challenging most of my career. Traditionally, when we were looking at sizing that outdoor unit, we sized it based on cooling capacities. That was the primary focus. When we start talking about these incredibly high heat capacities at ultra low temperatures, we are now challenged to relook at our pieces of equipment, particularly from the heating side. So, where we would have at one time selected a heat pump based on cooling capacity, now we can relook at our heat pump options based on heating capacity, because many of these units can be installed in, like, say, if I got a 5-ton unit, that's 5-ton in heating, but in cooling can actually be limited by RPSs to run on a smaller duct design system. Right. And so we're going to see pieces of equipment that can produce more heating capability than they do cooling capability. And people go, what do you mean? I was like, well, let's just sit down and look at an extended heating data chart and we'll actually show you. So the capacity of these things are very, 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 very good. So Paul had a question. Very good point, right? So when we start seeing temp drops with the lower temps, absolutely. So we're going to start seeing, when you look at those charts, you'll see our drops in BTU capacities as we start reducing. But the beauty of an inverter is that many of these inverters are not maxed out at heating capacity at 47 degrees, right? They're maxing out at heating capacity when they start getting down into these, 10 degree and 5 degree. So where we traditionally would think of a heat pump, especially like a single stage or a two stage, when it's in heating, it's just maxed out. And so we continue to lose BTUs as the temperature drops because we don't have as many BTUs outside to transfer, right? Our compressor's at a fixed speed. When we start getting into inverter technology, I don't need to be running at 100% capacity at 47 degrees. So my BTU rating at 47 degrees may actually be significantly lower than it is at 15 degrees, because we can start re-ramping that compressor to meet the actual BTU loads that we need. So when we look at those extended heating data tables, don't be a bit surprised to see more heating capability at 5 degrees than you have at 47 degrees.
Mm-hmm.
Depending
Yeah,
on.
and actually, that was a question that came up, and somebody asked me maybe a few weeks ago was, "Wait, why is it lower over here?" And I was
Yeah,
like, "Well, you're not going to need it there.
exactly.
So run the compressor lower, run it more efficiently."
Yeah. And so when we look at those capacities, you'll see cooling capacities and heating capacities, like cooling capacity at 95 and heating capacity at 47 being significantly lower than heating capacity at 5 degrees, and go, wow, how am I doing that? Well, we're doing that with more advanced technology like our inverter driven compressors and our advanced vapor injection. So maybe this is a good time for us to swing over to that next slide. Unless there's some things that we still want to cover on this one.
Good to hear.
Okay. All right. So let's talk about the equipment. So for those of
Yeah.
you from the industry that are familiar with our traditional refrigeration cycle on our heat pump, this is not going to look much different to you, except for another component or two. Right. So
Yeah.
it's an ingenious adaptation of traditional heat pump, inverter heat pump technology that just allows us to push the boundary of our compressor and from our operating envelope. So you guys want to dive a little bit into what this enhanced vapor injection is doing on the system?
Yeah. So what you can see here is basically a schematic of what we've got going on for the Ultra and the enhanced vapor injection. The outside of this loop we can see is basically our traditional refrigerant system, right?
Right.
So we've got our compressor up top. Since we're in heating mode, our indoor coil is going to be our condenser. And then eventually we'll go to EEVA, that's our expansion device, and then we're going to go to the evaporator, the outdoor unit, right? And we understand the way the refrigerant cycle is going to work in this case. And I would definitely recommend anybody who wants to dive deeper into this topic. The pH diagram is really kind of the holy grail. Is understanding that really unlocks the magic here. But so what we're going to do is we're going to go through the condenser just like we normally would, and we've got a set point for the indoor temperature for how hot we want that coil to be, and that's really driven by the customer demands, right? We want to maintain comfort for them. We want to maintain satisfaction. We want to ensure that we're providing them comfortable heat. So we don't want to sacrifice that. But what we do want to do is we want to increase our capacity at really low temperatures. And if we look at a pH diagram, what we really want to do is expand the width of it. And essentially, one way to do that is to increase our subcooling past the condenser.
Okay.
We don't want to do it in the condenser because that's going to decrease our outlet temperature.
Transfer.
Right?
Yeah. Mm-hmm.
Yeah. And our heat transfer is going to diminish as well.
Mm-hmm.
So we don't want to do that. But we have this clever way of what we're going to do is we're going to split the flow. So we're going to take most of the flow and continue on the main cycle, but we're going to take a small portion out of it. And I would say, kind of rule of thumb-ish, if we were running this at max, we maybe pull out 10%.
Oh, okay.
No,
All right.
no more than 10-ish.
Okay.
And what we're going to do with that is we're going to send it through an expansion device. This is going to be EEVC.
Mm-hmm.
So this is an expansion device for this loop. And we're going to take it to an intermediate pressure and temperature. And then what we're going to do is we're going to cross this through a plate heat exchanger.
Right.
And this is going to go counterflow with our main flow. And essentially what we've done is we've chilled this extra little bypass, right? And we're going to boil it off by crossing it with our main flow. And that's going to increase our subcooling. And it's actually going to increase our subcooling beyond, let's say, room temperature, right? If we had an infinitely sized indoor condenser, indoor coil, the best we could ever do is room temperature or whatever our return area is.
Sure, absolutely.
We can't get any better than that.
Right.
But in this case, we can get a little bit better than that. And that's what we're doing. And now when we go through our main expansion device, we're further to the left on the pH diagram, which means our outdoor unit can absorb more heat. And that's where we're really buying back that efficiency and buying back that increased capacity.
So we're really just adding a third metering device in our plate heat exchanger. And so for someone who is new to this ultra low temp environment, it's really not super significantly different. Yeah, we're going to have control algorithms. It's going to be monitoring things a little bit different, but we're still just using pressure transducers, temperature thermistors. We're doing all the calculations in our control boards. So physically, we're really not overcomplicating the circuit. We're simply adding an additional refrigeration circuit within our network to bring some additional cooling back into our compressor.
Yeah. And so, like you said, we're going to have sensors. So we've
Yeah.
got a sensor on the inlet and outlet of the plate heat exchanger on that
Right.
injection loop, and we're going to be measuring the superheat of that. So we're going to be modulating that EEVC to make
Absolutely.
sure that we completely boil it off before it goes into the compressor. This is also going to be a special vapor injection compressor. So this will have 2 inlets and 1 outlet.
Okay.
And then each of the inlets, so your main flow is going to have a full-size accumulator.
Yep.
But then your injection inlet is also going to have a mini accumulator on
Oh,
it.
no
And
kidding.
that's so when the system
Sure.
starts from rest, it's
Yeah.
always going to draw
Yeah.
gas.
Exactly. No pulling liquid back into our pump. Yeah.
Mhm.
It's great. I mean, it makes sense to me when you think about it. It's like, okay, how can we make the most advanced heat pump on the market? You want to subcool some liquid?
Let's just make it wider. Make
Holy
the pH wider.
Okay.
Yeah.
And we do have some of those diagrams. So if anyone in the chat is interested in looking at that, we can dive, and we're all HVAC nerds here. We can dive deep in this. We wanted to make
Yeah.
sure we were hanging out at that 1,000-foot view so that you're comfortable bringing this technology into the classroom and into your, your contractor training facility, getting the students and the technicians comfortable with it, because it's really what we're trying to do is we're trying to help break that stigma of a new technology, because many people are like, oh man, this new technology, they're just going to be miserable, and then they're just going to have so many control boards, they're just going to melt. And well, if you've already started working in the world of heat pumps and you've already got a general functionality of an inverter and you've got a general control of an electronic expansion valve, it should really make sense to you. It's nothing crazy drastic. It's just been well engineered to get maximum performance out of it.
Mm-hmm.
All right. Over in the chat, anybody got any questions? Because surely you got to be looking at it now going, okay, I see that. And I think I can handle this and not be completely overwhelmed with the transition. Okay. What do you think?
I hope we haven't stumped everybody.
I know. Oh, okay. Well,
I mean, the video at the beginning did an excellent job of showing it too. And that is really so we took the CAD from the inside of the unit, and we worked with the animation team to animate that whole process.
yeah.
Too. So that's really what it looks like.
And it's a fantastic animation. I'm actually trying to see if we can utilize that in some training going forward. This is a good moment for me to go back and regroup on that just for a second. For those that weren't with us at the beginning of the show, this is a really, really good animation to take a peek at. So I'm going to replay the intro. I'm also going to throw some QR codes out here for people to take a look at things. One in particular is, how do heat pumps work in cold climates? All right. So this is a resource from Bosch that you should go take a look at. They'll dive a little bit deeper into some of this, give you some product information. If you want to learn more about the IDS Ultra in particular, here's a good link for that. And I'll come back with some other QRs for some refrigerant guides, A2L guides, and some IRA information as well. But I think we'll hop back over there. Oh, one more came in. I see a valve ahead of the EEV. Yeah, sure. Let's talk about that solenoid just a little bit before we hop
Yeah,
up.
that's an excellent question. So when we're at moderate temperatures, or even when we're in cooling mode, so
Yeah.
the way this is positioned, this is always on the receiving side of the indoor unit. So when you're in cooling mode, this is something that we're not going to need,
Yeah, we don't need it.
right?
Yeah.
And the refrigerant flow would be reversed.
Yeah.
So what we're going to do is we're going to close that solenoid valve to ensure that no refrigerant is going to go through there. And that ensures that we don't have to use all of the capacity cranking down EEVC to close, because those valves are going to have some amount of leakage anyway. So we're going to take and close that solenoid valve for the cooling mode, but also at certain temperatures for running the heat pump, you don't need that extra capacity, right? We talked about it before. You're not going to be running necessarily at 100% duty cycle for the inverter.
Exactly.
At moderate temperatures, so you're not going to need it.
If I don't need it, I'm just running like a high SEER heat pump until I need the extra capacity.
Yeah, but there is a slight added benefit of starting to run that earlier, even at slightly moderate temperatures. So our system actually starts to open that solenoid valve between 50 degrees and 40 degrees. And part of the reason for that is because you can absorb more heat, your compressor doesn't have to work as hard for the same capacity. So you can decrease the compressor speed, and that's going to save you on energy, but it's also going to help reduce noise.
You bet it would.
As well.
Yeah. And then we're bringing some cooling back to the compressor, so we're maximizing the life of the compressor. Man, I'm glad we did this. This is a really good conversation. Okay, so be thinking about the community. Be thinking about some questions that you want. Put them in the chat. We're going to hop back over, go through that animation real quick. It's about 3 minutes or so. It's not very long, and that'll let you see the working of it a little bit better. And then I'll see you all here in just a couple minutes.
Welcome to the next level of home comfort with the Bosch IDS Ultra Inverter Ducted Split Heat Pump. Engineered for extreme cold, this advanced system ensures efficient heating down to minus 13 degrees Fahrenheit and offers seamless cooling for year-round comfort. Powered by Bosch's inverter technology and featuring low GWP refrigerant, the IDS Ultra is designed to meet modern energy needs while offering unmatched reliability in any climate. Take advantage of significant rebates and tax credits, such as those provided by the Inflation Reduction Act. For example, households with income below 80% of the area median income can receive up to $8,000 in rebates for installing a high-efficiency, ducted split-system heat pump. Plus, a 30% tax credit on installation costs up to $2,000 annually is available through the Residential Renewable Energy Tax Credit. With lower energy consumption, a heat pump can potentially help reduce your utility bills over time. Unlike traditional on-off compressors, the Bosch inverter compressor adjusts its speed in 1% increments to match the cooling or heating load precisely, significantly reducing energy consumption and operational wear. This variable capacity allows for superior temperature and humidity control, operating between 33% and 187% to meet your home's exact needs. The compressor modulates its speed to achieve the indoor coil target temperature with specific target ranges for heating and cooling. This eliminates the risk of freezing the coil while providing superior comfort and dehumidification in cooling. With features like accelerated cooling mode and variable speed indoor air handler, the Bosch IDS system provides enhanced humidity control, making your home more comfortable. The new Bosch IDS Ultra features an innovative technology called enhanced vapor injection to enable efficient heat pump operation in cold climates. Enhanced vapor injection is enabled by the addition of a plate heat exchanger, an additional electronic expansion valve, and complemented by an inverter compressor. The system operates much like a conventional heat pump. When additional capacity is needed at very low temperatures, an expansion valve opens to allow a portion of refrigerant to bypass the traditional cycle. The vapor injection process begins as a portion of the liquid refrigerant is diverted through an expansion valve into the intermediate heat exchanger, transforming it into a cool vapor. This diverted flow is used to further subcool the main flow after it has passed through the indoor coil, heating the inside to the desired temperature. This ensures consistent and comfortable indoor temperatures. By lowering the refrigerant temperature after leaving the condenser, more heat can be absorbed from the cold air by the evaporator, extending the heat pump's operating range down to minus 13 degrees Fahrenheit, making Bosch heat pumps a great choice for colder climates. Pairing Bosch IDS products with the correct air handlers, furnaces, and cased coils is crucial for peak performance. Bosch IDS systems are designed to work with most 24-volt AC thermostats, seamlessly pairing with a variety of third-party air handlers and furnaces, ensuring broad compatibility and installation ease. Always consult Bosch's model compatibility charts and installation manuals to ensure proper system matching and optimal performance. Our certified expert installer network is ready to assist with installation if needed. Designed with contractors in mind, installation and maintenance are streamlined, ensuring seamless integration and longevity while meeting the demands of homeowners and builders.
I love that diagram. I mean, when you look at that video and this diagram hand in hand, it's just it's beautiful. It's very simplistic, but very efficient.
Yeah, thanks.
And I'm very excited to see this come to the industry. I do have one question. As a controls nerd,
Hmm.
when I watch this video, I hear something that I wanted to ask some questions about. With the target temperature, evaporator target temperature, is there any means of adjusting that for like dry mode or changes to the evaporator target temperature, like in cooling mode?
Mohamad?
So the evaporator temperature, specifically for um, dry mode and humidity, we have humidity control
Yeah.
that is specifically for this heat pump. So this heat pump comes in communicating.
Yep.
So when there is a call for dehumidification, it knows and it adjusts its blower speed and its compressor speed accordingly. So according to what the dip switch on the blower is, it adjusts that in order to maximize the comfort and reach the humidity set point that is called on by the homeowner and the thermostat.
Mm. Yeah, I love that. And yeah, Jim, you're exactly right. I'm so glad you joined us today. I really appreciate you being here. Love to have you here more often. If you want to hop on the show sometime, Jim, please let me know. There's so many things that we can bring elevated education to the industry with. And yeah, that's really what we're doing. I mean, when you think about the principle of it, it just makes sense. The reason I brought that up with the evaporator target temperature is there are, particularly in the South, we have complaints of contractors that struggle with inverters and dehumidification. And I think it's because they're just not as well educated on the function of variable speed blowers and their effect on capacity with an inverter. If we talked
Mhm.
about a traditional system, not what I said, I know we're talking about heat pumps, but I'm wanting to shed some light on the importance of this technology in the cooling mode as well. Like if we talk about a traditional single stage or two stage unit, if we were wanting to adjust our evaporator target temperature, we simply changed fan speed, right? Because our capacity didn't change, right? So we changed our sensible heat ratio by changing the airflow across the evaporator. And so many technicians are stuck with that same mentality when they get into inverter technology and they go, "Oh, I'm not dehumidifying enough. I'll just reduce my fan speed like I used to do," not realizing that because we have target evaporator temperatures, if I reduce fan speed, all I'm doing is reducing capacity.
Yep.
That's it.
Now
So
this heat pump knows and it handles that accordingly. So it adjusts the compressor speed to where it needs to be, and it lowers the fan speed. So you won't be just reducing capacity, but you will also be maximizing humidity comfort.
exactly. And so for those that are struggling with understanding dehumidification capability with an inverter, I do believe it's just because you haven't given us the chance to show you the benefit of the inverter for dehumidification, especially when we have dry mode. Because in that dry mode, we're probably going to adjust that evaporator target temperature down a little bit. We're going to reduce that fan speed. We're going to do just exactly what you were saying, Mohamad. We're going to maintain based on a humidity control versus the traditional temperature control and changing fan speeds to adjust humidity. So the capability of these systems in southern climates are more important than we have thought of traditionally. Because we
Hmm.
started looking at these cold climate heat pumps, and we have a lot of our country going, it doesn't get cold enough to need a cold climate heat pump down here. And then I go, are you struggling with dehumidification? Maybe you just need a slightly more advanced piece of equipment to do that dehumidification. And oh, by the way, you're not going to need any electric resistive heating because your heat pump is now capable of your full heating load. So we've conquered heating capacity in the heating mode, and we've conquered dehumidification in the cooling mode all in one piece.
Yeah, that's right.
You got
Yeah,
it.
and I think you said it. Setup is really important,
It is.
right? Is knowing that that function is there and available, and setting it up out of the box when you commission it
Yeah.
is critical to
Yeah.
getting that level of quality and comfort.
Yeah. It's really comes down to understanding the pieces of equipment. You know, Trevor, this is probably going to this is probably right up your alley. When we talk about automotive, um, what would I call them? I wouldn't call them engineers. When I talk about automotive owners that utilize the technology to get maximum performance out of an engine, it's because they've
Hmm.
understood how the controls work, right? Uh,
Yeah.
I could take a 150 horsepower four cylinder and turn it into a 300 horsepower four cylinder if I know the controls, right?
Hmm.
A car is going to come with a predetermined set of controls, but that doesn't mean they can't be modified for more performance or more fuel efficiency, right? That's the reason
Yeah,
we have those
exactly.
different modes in our modern vehicles. We're just shifting the parameters on our algorithms around a little bit. When we
Hmm.
get into these more sophisticated pieces of equipment, we need to understand, yes, out of the box, it's probably going to come with a program that should work pretty decently. But the more I can understand that piece of equipment and its capability, now the better of an installation and commissioning I'm going to do. Because you're right. If it's not
Yeah.
sized and installed and commissioned properly, it will never get the maximum performance out of it.
Yeah. And one thing you mentioned before too, duct sizing and airflow. With inverters, you restrict the airflow, you reduce capacity.
Same thing again.
Because
Yeah.
it's looking at that return refrigerant and modulating the compressor speed to match it so that the vapor quality coming back is always the same. But if you reduce the airflow, less can boil off or condense. So it's going to
Mhm.
modulate itself down. So you need to make sure that your ductwork is sized properly too. It's not going to want to overcome that on its own, right?
Exactly. Yeah, that's one of the biggest misperceptions when we talk about airflow. People say, "Oh, those variable speed motors, those ECMs, they'll overcome some static pressure." No, they don't. There's always a negative benefit. And the same way with our inverters, there's always a negative benefit. So it's going to be extremely important to understand the similarities of these new pieces of equipment and the differences of these new pieces of equipment so that we're doing the proper installation. It's not a unbox, plug and go scenario, which some of our contractors have utilized in the past. We have to spend a tad bit more time on setup. But when we do, now we've got customization.
Hmm.
Now we can really do some amazing things with this very advanced piece of technology.
Yeah. And
And
a
it got me
product that can
excited. I
fit
can't wait to get
so
home.
many regions.
Yeah, that's it. That was the reason of calling this heat pumps for all climates. Do I need a cold climate heat pump in the South? Maybe.
Maybe
If
there could be some benefit. Yeah.
absolutely, if I'm looking for a piece of equipment that I can get rid of my electric resistive heating and I can have a unit that can handle my heating capacity and my cooling capacity with incredible dehumidification capability, maybe
Mhm.
that cold climate heat pump actually is the best option for you. But it's important to compare all of them, to have an understanding of what we're working with and to know that any climate that you're in, there is a solution. And Bosch has provided solutions all the way from that 15 SEER all the way up into our new IDS Ultra.
Mhm.
So
Mhm.
That
big,
is
big
correct.
changes in our industry.
Mhm.
All right, we're getting to the end of the show, guys. Any slides we want to go regroup on? I did mention to everyone that I was going to bring up some additional QR codes. Let me hop over there real quick. So when we're talking about those rebates, right? It makes sense when we start getting into higher performing pieces of equipment. They're going to be more incentivized federally, locally, right? So you want to make sure that you get a little educated on these IRA rebates and what that means to the industry. Particularly if I'm a contractor, this is a fantastic resource for you to start looking at your equipment going, well, maybe I can start using a top tier or maybe a fourth product lineup that financially competes with some of the product lineups below that because of a variety of incentives, tax rebates, and IRA rebates. And as we make this transition into A2L refrigerants, I know Bosch has been utilizing R454B. So for those contractors that are just now starting to be caught with their pants down that R410A is going away, which they do, we're still getting these calls. What do you mean 410A is going away? Well, yeah,
God.
it's pretty well gone. we're,
Mhm.
we're dwindling down the supplies now. So if you need to get more familiar with the Bosch R454B transition into equipment, we have the A2L refrigerant change guide. And so those are good
And
resources and references for you.
don't forget your left-handed adapters, tank adapters.
Exactly. Buy 5 of
Mhm.
them, right?
Yeah.
I would
If
probably
you're a
have,
counter guy, make sure you
yeah.
offer them. Get
Yeah.
shakes with that.
Yeah, it's an important piece to have. When I look at adapters, I've still got, I'd have to dig for a second, but I've still got all of my 100-pound tank adapters from when I was doing commercial refrigeration. People are like, well, why do you got 4 or 5 of them? I was like, because I may
It
have
happens.
2, and then next week I might have 3, and then I might get lucky and find the 3 that I lost a couple of weeks ago. And so they're not expensive, they're worth having, or look into having a dedicated manifold set where you're utilizing hoses. I know Navac is doing some specific A2L hoses that already have the left-hand threads on them with a orange indicated hose, so you have a separate manifold set. I personally, as a technician, would have a separate A2L manifold set, but that's not required. It is an optional item from the industry. All right. Let's any additional resources. We'll make sure we get everyone over to Bosch Home Comfort.us. Learn a little bit more about Bosch products. Gentlemen, anything else we'd like to cover while we're here?
No, I think we're good. Yeah.
All good from my
Excellent
side.
questions. Love the crowd.
I mean, there's so many things that we can dive deeper into. I mean, I'm going through those slides going, not everyone out there realizes that on that second set that we use, like 2 or 3 slides, there's actually 33 slides just in that deck. I mean, that's a whole show. And I know Phil Raines from your team is wanting to do an episode and dive a little bit deeper into the vapor injection side and start looking at it from the technician perspective. What does it look like when I peek my head in there? We've seen some animations, but we'll dive a little bit deeper into that along the way. And if there's any other questions or comments from the community, we definitely love to hear more.
I did see one there about hyperheat, and that's pretty analogous to flash tank vapor injection.
Okay.
FYI, which is what you would see in our Max Performance mini split.
In that ductless system.
So it's a slightly different flavor, but it's the same underlying principle. But there are some differences between the two technologies.
Yeah.
And that 30 slide presentation actually does cover that. But that could take a whole hour to go into just that topic.
Absolutely. All right. Well, we are right on top of the hour. Gentlemen, I appreciate you so much. I look forward to hanging out. Are either one of you going to be at AHR?
Yeah, I'll be there.
Yes.
Excellent. All right. We'll have to hook up Mohamad and we'll see what else is coming to the industry. And we'll definitely all regroup in the near future and start diving into some heat pump water heaters and ways that side of our industry is changing. So we're grateful that you all joined us today. We're thankful that Bosch is partnered with us for education for the industry to help bring knowledge to the masses. And we will.
Thanks for having us.
Yeah, this is great. All right. I don't see any other questions out there. Trevor, Mohamad, thank you for joining us.
Thank you.
Have a great day.
Bye.